you would take this offer. You can have any superpower that you want, or just any of them. But to use the superpower, you have to make the noise that corresponds. So, like, if you're flying, like, if your power is flying, you have to go, yeah. You have to make the noise. And as soon as you stop making the noise, it doesn't work anymore. Yeah.
Okay. I'll think about it.
Think about it? Okay.
Mm-hmm.
Thank you. Can you write me, like, an essay for it?
Yeah, a thesis.
An essay?
Yeah.
An argument. I am done with school for a reason. After my 50-something page action research paper I had to submit for my master's, I was like, done. My professor made the mistake of saying, hey, just keep resubmitting it to me and I'll keep going through it and proofreading it for you. So she would proofread it. I would literally go through and click all the things she said to correct, and I'd send it back. And then she'd do some more, and I'd be like, click, click. There you go. That's her fault. But yeah, I survived. Got my master's. Okay, so now that we've learned the unit circle, if you've got a notebook or a binder with that clear sheet in it, that's a good place to put your paper plate so it kind of just smushes in there. And then you can also still see it. Put it in a notebook, put it in your Chromebook if you want to. It'll flatten out eventually. And then if you have me as a pre-cal teacher, we'll do it again. If you don't have me as a pre-cal teacher, you have that, then
Can I bust this out and be like,
you can be like, I'm good.
Wow.
Okay, so we are going to go over right triangle trig.
My favorite.
Okay?
what's my favorite kind of
For those of you who are familiar with SOHCAHTOA,
Yeah, we are.
this is something that is just going to be pretty straightforward. Are you still with us? Good morning. But some of us, and it happened in my 7 a.m., I said SOHCAHTOA, and someone was like, what did you just say? Okay. That's just how to remember these. Okay. So, like I said, some of us have never seen these trig functions before. I know you have not seen a lot of those. But then even sine, cosine, tangent. So I'm going to write these out what they actually are. This is sine. This is cosine. And this is tangent. Okay. Over here, this is cosecant, secant, and cotangent. Okay, so when I say those words, that's what I'm actually saying, but those are their abbreviations for it. Sine, cosine, tangent, cosecant, secant, and cotangent. There's a reason why I have them laid out the way they are. You want to make sure cosecant's across from sine, secant's across from cosine, and cotangent's across from tangent. Okay, so something you will see is this symbol right here. This is a Greek letter, theta. They like to use the Greek alphabet with angles. Theta, alpha, beta, gamma. Okay, they like to use a lot of those. So that just kind of denotes an angle measurement. So I'm going to put theta down there in that corner closest to the origin, okay? You're always going to have your angles closest to the origin if you are given an x and y axis. What's the definition of a hypotenuse? Yeah, the longest side, okay? So that's the longest side, which is over here, that's our hypotenuse. It is also directly across or opposite from your right angle. Okay? Hypotenuse is directly across or opposite from your right angle. Okay, depending on where theta is where your opposite and your adjacent lie. Okay? So theta is here, go directly across, that's my opposite. Because it is across, it is opposite from theta, which makes my adjacent down here. Okay? So when you hear me say, so, Toa, this is what I mean by that, okay? Sine is your opposite over hypotenuse. And I'm actually going to write that in, opposite over your hypotenuse. Which makes cosine your adjacent over hypotenuse. And then your tangent is your opposite over adjacent. So that's how we get SOHCAHTOA. I know there was a teacher that used to use the abbreviations. Some old hippie came a hopping, tripping on acid. You can remember out that way too if you want to. The first time one of my students, I was like, have y'all ever heard of SOHCAHTOA? And then I'm like, some of them were like, no. And then I wrote it out and they're like, oh, you mean, and they just rattled that off and I was like, what? But then it helped them remember. So SOHCAHTOA is what I'm going to stick with.
I like the other one better.
That's fine. You stick with it.
Can you say it one more time?
But I thought you liked it.
Well, yeah, but I didn't, I wasn't expecting it, so I didn't. I wasn't prepared.
Some old hippie came a hopping, tripping on acid.
Yeah.
Yeah. If you want to keep it PG, you can put some old hippie came a hopping, tripping on apples.
No.
Like just fell over apples.
Johnny Apple says you do. You know that dude was a hippie. Don't you worry.
Okay, so if I take sine, and like I said, there's a reason why cosecant, secant, and cotangent are the way they are, across from the things that they're across from, is that you can take sine, flip it. You got cosecant. Take cosine, flip it. Whoops. As I put an A here instead of an O. Oh man, gotta change my color back. And then if tangent was opposite over adjacent, then cotangent is adjacent over opposite. Okay, so they're just flip-flopped. They are the reciprocal function to sine, cosine, and tangent. Okay, not the inverse. We'll get to those here in a little bit. So for those of you who may have missed this in geometry, you're probably like, wow, this is a little overwhelming, especially after doing the unit circle. Trust me when I say when we do an example, it's not going to be overwhelming. Yeah.
So how do you know which one is opposite and which one's adjacent?
It's from theta. So looking at the angle that you're interested in, opposite is literally opposite from it.
Will they always tell you which one is theta or is
Uh-huh.
Okay.
If it's a word problem, they'll tell you angle of elevation, which usually means down here, which we'll look at those two.
Couldn't they give you the opposite and ask for where theta would be?
Could they give you the opposite and what?
Ask where theta would be? I mean, that is the same thing.
Yeah, but they normally don't. They might give you opposite and adjacent and ask for theta, and we'll get over those two as well. All right, so here's what I mean. Let's try our first one. How do we find a missing side of a triangle? Pythagorean theorem. So at UT, yes, UT, you have to major in math and minor in education. So if you all can imagine what I call true math majors, and then there's us, we're in a lot of these classes together. Well, we had to do a presentation on something in our analytical geometry class. And me and another girl that was going to become a teacher, chose Pythagoras. Well, naturally, if you want to please anybody, you make food. So we made these cute triangle cookies and everything like that. The professor blew us apart because we did that. And I was like, you got to play to your judge is what's got. We thought we were like, hey, this is fun, this is cute. And he was like, you could have done more math on the board and just make cute little cookies. He was not the nicest person. He also told me I was too dumb to get a math degree.
Oh my God.
Hey, he made you feel wrong.
No. And if y'all really knew me, I don't cry. So if you ever see me crying, like, run away. So,
Run away.
Yes,
That
run
seems
very
more
far
like
away.
a rant
So if I start crying,
Not like help you? Not be
It's-
like,
no,
hey, what's
you
wrong?
run. Because I'm either really mad
No, she's making the
or
noise
in
for a
pain
superpower.
or very stressed.
If you're in
So,
pain, why wouldn't we help you?
no, you run.
Go, save yourself.
Yeah, save yourself, exactly.
She'll explode.
But no, after he told me that, because I was at that level of stress and mad at the same time, started crying, and I was like, I'm too dumb to be a math major. And yeah, it was a dark day.
That's the kind of teacher I need.
Yeah. Hey, they exist all through college.
Yeah.
They don't have to worry about mommy and daddy and grandma calling anymore. They're like, I'll tell you how it is. And I'm
Oh,
like,
they'll call.
okay, so what did y'all get for your C value if you did do Pythagorean theorem? 17? So since some of us are just starting out learning this, I would go ahead on your triangle, write out where your opposite is, where your hypotenuse is, and where your adjacent is, because then once we start doing these problems, it'll make your life easier. So I would look at theta, and I go directly across. That's my opposite. My longest side, of course, is my hypotenuse, which makes 8 my adjacent. So again, since I'm just starting out, I'm going to write out what everything is. Do I have to show that? No. So now it's literally just plugging in numbers. So sine is my opposite over hypotenuse. That's just 15 over 17. If it can be reduced, reduce it. If it can't, that's it. So that would make cosine what? 8 over 17. Which makes tangent 15 over 8. Good news is the other ones are directly across from it. I just flip them. Sine makes cosecant 17 over 15. Then 17 over 8. And then 8 over 15. you flip it. So that's the important part. You have to make sure that you know that sine and cosecant are reciprocals of each other. Okay? Here's how I remember it. I say if I have, notice how it's sine and cosine starts with an S, starts with a C. Notice how the S's don't go together and the C's don't go together. That's how I know that they, I mean, you can probably think of another way to memorize it, but for me, I'm like, it's not sine and secant. It's sine, cosecant, and cosine and secant. So they don't match up with the letters. And of course, cotangent and tangent go together. It makes sense. Okay, let's try another one.
Let's see.
Make sure we're all on the same page. What does B equal? 24.
What?
So you should have 7 squared plus B squared is equal to 25 squared. And then solve for B. Is it 225? And that's 15. Sorry. 25 squared,
625.
625. Okay. So who has my sine value? Remember, theta's up here now. Theta's up here, so 7 is my opposite. That's my adjacent, and that's my hypotenuse. 7 over 25? Okay, someone else tell me cosine. Okay? 4 over 25. Tangent? Anyone got my tangent answer? Yeah. 7 over 24. Good. What about cosecant? You already answered one. Cosecant. All right, what you got?
25 over 7.
Yep. As simple as that. Secant? Okay.
25.
Yep. And cotangent. Do what now?
What? The number
24 over 7?
Oh, I didn't know you were saying 4, and I was like, you just got 4? Okay, so again, if it is new to you, then yes, this was probably something you saw at the beginning and you were like, what's going on? Okay, but hopefully now you see it's not a lot to it. Okay, this is the good old feeling of trig that you can hold on to. Yeah.
What's it for?
For solving triangles. We're going to do some real world problems in a second. Okay. All right. The only thing that will be different if you come across a problem like this is you'll have to, and we won't go through all 6 trig functions, but I'll show you how to set this up. You're just going to literally plot this point. So if you went -4, +3, then you would plot that point and you would draw a triangle. And then, so if this is -4 and this is 3, now you have a triangle, okay? But you can do all 6 trig functions. Remember, you're always going to pick that as your theta, the closest to your origin, just like before, okay? The same rules of that apply. That's not anything different when you have to find all 6 trig functions from there. Just acknowledge that negative. Don't forget about the negatives. But I do want to get to some real world problems as soon as I can before time runs out. Okay, so let's look at this one. They live for these. Those ladder problems. A ladder is this much whatever leaning up against a building. How tall is the building? Once you go through like 3 of these, you're like, seen it, done it. Okay? So, the hardest part is setting up the triangles. After that, it's a breeze. So, from a point on level ground, 125 feet from the base of a tower, the angle of elevation is 57.2 degrees. Find the height of the tower. Okay? So, what would that make 125? Yeah, this down here, this 125 is my distance here. Your angle of elevation is going up from your horizontal. So wherever your horizontal is, it's going up from that. So that's 57.2 degrees. They want to know the height of the tower. Okay, so which trig function uses the opposite and the adjacent? Tangent. So let's set it up. Tangent of 57.2 degrees is equal to my opposite, which I don't know, over my adjacent. You literally see a degree symbol in the problem. That should be your red flag that your calculator needs to be in degree mode. Okay? So you see, like I said, literally a degree symbol. That's going to tell me I need to make sure my calculator is in degree mode. All you do is click the mode button. So newer calculators, y'all see where it says degree or radian at the top? If you need to switch it, just go to mode and go down and switch it to degrees. So then now, tangent, which is over here above the parentheses, we just type it in. 57.2. And to get x by itself, I'm just going to multiply by 125. And it's set to the nearest foot. So 194. So they can come up with all different types of combinations of this. All you have to do is say, what is this my opposite? Is this my adjacent? Is this my hypotenuse? Okay, once I find that, then I can do, I can plug it in my calculator from there. Okay. One more type of problem that you would see that you're might not be familiar with And they can tell you any kind of shape or fashion of this one. I am missing the angle measure. Okay? So the angle of elevation, again, from your horizontal going up, we want to know what that is. So what is 10 to that spot? Opposite. What's 45? Hypotenuse. Which trig function uses the opposite and the hypotenuse? Sine. So we would set it up. Opposite over hypotenuse. Okay? When you do not know the angle, you will use the inverse button in your calculator. Okay? When you do not know the angle, you will use the inverse button in your calculator. So I'll show you. In your calculator, notice how you can click second sine, because it has a little -1 with it. Second sine. Then type in 10 over 45. And your angle of elevation is just 13 degrees. Very small. Okay, so you're going to do second sine, and you'll see that little -1 pop up. And that's how you find the angle if the angle is not given to you. Okay, and you're going to use that button a lot tomorrow and the next day as well. Okay, for law of sines and law of cosines. Okay. Like I said, try majority of